Lewis structures and resonance. We're going to look at the nitrite polyatomic ion, which is NO2 minus. And we're going to do this using the nasal technique. Remember, this stands for how many electrons do you need? Next, how many valence electrons do you have available? After that, we're then going to subtract and divide to get the number of bonds. And after we get done with that, we're going to look to see how many lone pairs should there be. And that will give us the nasal technique. So, looking to see what we need, we have one nitrogen, and each one of those nitrogens needs 8 electrons. We also have 2 oxygens, and each oxygen needs to have 8 electrons. This gives us a total of 24 electrons. Next, how many do we have available? We have one nitrogen, and each nitrogen has 5 electrons available. We have 2 oxygens, and each oxygen has 6 electrons available. Once again, we're looking at the valence electrons. Now, this particular polyatomic also has a charge of -1. So that is also available. We have that extra electron in there. We do that for polyatomic ions. We add it if it has a negative charge, and we subtract it off if it has a positive charge, because those electrons would be gone if it had a positive charge. In this case, since it's a -1, we have to add 1 electron to it. So our total amount of electrons available, 1 times 5 plus 2 times 6 plus 1, gives me 18 electrons. Now, we subtract. We need 24 electrons, but we only have 18. So what this means is that we're going to have 6 electrons that need to be shared. If we have 6 electrons that are shared, let's then take the 6 electrons, divide it by 2, and that's going to be 3 bonds. So 3 bonds will be formed. Now let's figure out how many lone pairs we're going to have on these. This will help us draw the picture. We have 18 electrons available, but 6 of those electrons, from up here, 6 of those electrons, oops, let me write 6, are actually being used in bonds. So this gives us 18 minus 6, 12 electrons that are not going to be used in bonds. So number of lone pairs, we basically take 12 over 2, and that means 6 lone pairs, because they come in pairs. All right, they appear as pairs. So now I can go ahead and draw this Lewis structure. Well, the least electronegative element up there is nitrogen. So we put that in the middle. Now I have an oxygen on one side, oxygen on the other side. And to one of them, I need 3 bonds. So I'm going to put 1 bond to one of them, 2 bonds to the other one. Now I have to fill in with the lone pairs. I'm going to have my 6 lone pairs up there. Well, let's start with this oxygen over here first. It needs 8 electrons around it, so I'm going to give it 3 of the lone pairs. Now, the nitrogen in the center, it has 6 electrons around it. Each dash represents 2 electrons, so there's 6. So it needs 1 of the lone pairs. And finally, the last 2 lone pairs, to give me 6, I'll put on the other oxygen. Now, in order to do this, we have to indicate that this is an ion, so we put the negative charge with it. Now, can that be the only drawing that we can have? And the answer is no. You got nitrogen attached to the same 2 elements. So what I have to do here, this actually has resonance because it's bonded differently than to each of those 2 elements. So I am going to draw its second resonance structure. Assigning the proper amount of electrons around each element. And this would be my answer to the nitrite polyatomic ion.